Welcome to the first TechSpecs video presentation. In this video we're going to have a look at the TechSpecs Attached Structures program. I'm not going to get into too much detail at this particular point in time. It's just to give you a general rundown on the types of projects that can be designed and engineered with this particular program. When you first open the program, it opens to this sheet information page. Basically, this just gives you a brief rundown of the types of patios that can be built with each particular page. There's also some photos in each cell. For example, if you want to see a photo of the type of patio you can build with flat option 1, which is clearly just a very simple flat patio, or flat option 2, it's just a flat patio with a central beam. These photos just show you what can be designed with each particular page. This page is also fully customisable. You can change the photos in those comments, you can change these descriptions, and you can write in here any particular thing that makes the whole process a little bit easier, makes a little bit more sense for you. So first we'll just have a look at a flat patio. Clearly 99% of people watching this video or interested in this particular program would be more than capable of designing a flat patio, but this is designed for, I guess, people at all levels to use. It makes it much easier for new staff members or new salespeople to learn a little bit about engineering, and it also makes it very quick and easy for people who are well versed, I guess, in that part of the industry, as it's a much more simple method, I guess, than trying to explain to somebody how to use a specification sheet. It's a little bit more visual. First things first, we need to select our geographic region. There's a little pop-up window which will explain the geographic regions of Australia to somebody who's not aware of how to calculate it. That will make it a little bit easier for them. So from there we select region A, B or C. Obviously if we select region A or B, we'll have wind categories of N1 to N4. If we select region C, we'll have wind categories of C1 to C4. So for now we'll just stick with region B and a wind category of N2. From there we have a number of coefficients to choose from. Some patio companies use coefficients, some patio companies use the number of sides enclosed that a particular project is. So in this instance, when you select the coefficient, it tells you in the cell underneath it how many sides enclosed that is. So each time you make a different selection, it will just tell you underneath what that particular selection is. So 1.1 is fully enclosed in N areas, 0.7 is 3 sides open, and so on. From there we select our post type, either aluminium or steel. At this particular point there'll be nothing available in the post size drop down box until all the rest of these dimensions, etc. are inputted into the program. It can't make the required calculations, so we'll come back to the post size shortly. From there we select our footing type. We have covered square footings in clay, covered board piers in clay, uncovered square footings in sand and Class M soils, uncovered board piers in clay, 100mm concrete slabs, and timber floors and decks. We'll just choose a covered square footing for now in clay soil. From there we select our roof sheet. There's close to 50 odd different brands and thicknesses, etc. of roof sheet available in the program. Obviously that list is fully customisable to whatever particular products your particular business requires. From there we put in the width of our patio, and in this instance it's from the furthest post on the left to the furthest post on the right. If we want to add overhangs to the beams, etc., then obviously that adds to this total patio width here. From there we select the number of posts, central posts that we want to put in. So in this case we're not going to get too many beams that will span 10 metres obviously, so we'll allow for one central post. So you'll see now it tells us our current beam span is 5 metres and our maximum allowable overhang is 1.25. So if we want to put an overhang on one end or the other or both, we'll put a, say, a 500 overhang on both ends, and you'll see it just formats the page a little bit just so that the certificate that you generate at the end of this process is similar to the documentation and plans, etc. that you submit to council or you certify. From there we put in our roof sheet span. We'll make that 4.5 metres, and the same thing, we can add an overhang to the roof sheet if it's required. So you'll see now we have a total patio width of 11 metres, which was the original 10 that we put in, plus our 500 overhang either end. And we have a total projection of 5 metres, which obviously is our roof sheet span and our overhang. From there we'll be able to select the post size. This instance we need a 65 by 65 by 2 mm aluminium post, and you'll see that gives us a maximum height of 3.2 metres. If we want to go higher than 3.2 metres, if we select the next size post up, you'll see that gives us a maximum height of 3.6, and if we go to the next post again, it gives us a maximum height of 4 metres. From there, we simply select our beam type. We have roll form beams, steel RHS, aluminium RHS, or F17 hardwood timber beams. We'll start off with a roll form beam. You'll see we need a 150 by 60 roll form beam. That data is easily customisable in the back of the program. Once again, if clearly every company's information on their roll form beams are slightly different, the program can be customised to suit anybody's particular product very quickly and easily. From there, we just need to add a customer's name and address, suburb, select a state, and the program will give us a postcode. There we put in a drawing number or a name. It's just something to refer this certificate to the documentation and plans, etc. you're sending to council. Put in our current date, and you'll see we now have design correct. From there, we simply print the page, and you'll see it gives us the page that we've just generated with our design correct and all the details. It tells us that the certificate is produced by the TechSpecs Attached Structures program. It's to be used in conjunction with the TechSpecs Engineering Design Manual, and that the program and the manual have been certified by Glen Tucker Consulting Engineers. Now the program is currently certified in Queensland, New South Wales and Victoria, and clearly can be certified in any other state if required. Also says that design correct must be displayed in the lower right hand corner of the page, which is clearly this section here, and all customer details must be correct. Then lists our web address, our email address, and my current mobile phone number, so that if either yourself or perhaps your certifier, after you've submitted this to your certifier or the council, if they have any questions or queries, has my mobile number on it so that I can be contacted at any time. If you leave any particular part of the page on select, for example, you'll see straight away our design's incorrect. And it highlights incorrect somewhere on the page to show you where the particular error is, so that you can go back and correct it quickly and easily. If, for example, you'll see our maximum roof sheet is 4.7, if we have 4.8 in there, you'll see our design's gone to incorrect, and over here it shows us incorrect next to where the issue is. So we either have to select a roof sheet that will span further than that, or if we specifically wanted to use that particular roof sheet, we can see that if we reduce this span by 100 mm, it will solve the problem. If you leave a cell, or if you select a blank anywhere, once again, design goes to incorrect, and you'll see incorrect shows up on the page and shows you where the issue is. You simply go back, select whatever is available in the drop-down box that will achieve your desired result, and the program goes back to design correct. Once you've selected your beam, if you want to have a look at the details of that beam or see how close you are to being able to use a smaller beam, you can simply scroll down to the page here, and you'll see we're currently using the 150 by 60 roll form beam, which is only using less than 70% of its strength capacity. It's only using less than 50% of its deflection capacity under wind load, and only 43% of its capacity for deflection under self-weight. But if you go back one beam and have a look at the 140 by 50, you'll see it's almost 40% over its strength capacity. So you'll have to make fairly wholesale changes to the dimensions or of the patio, or maybe add another post, for example. So if we scroll back up here and added a second post, so now our beam spans are back to 3 metres 333, and you'll see now the smaller roll form beam is available. Obviously the program will allow you to over-engineer something, so even if we take that post back out of there, and a 150 by 60 will give us design correct. You can use a bigger beam if you want to, you can use a much bigger beam or double beam. That's not an issue, it will allow you to do that, but obviously once a beam drops out of the list and you try and select it, or if you add a post, select the very small beam and then try and take the post out, straight away it goes to incorrect until you go back and fix the problem. Each beam is checked, as you can see down here, it's checked for strength, deflection under wind load and deflection under self-weight, and if it fails any one of those three checks, it immediately drops out of the list and is not available for use. So that's a quick rundown on the flat patio page. Like I said, it's very basic, very straightforward. Most people would know how to engineer a flat patio, but if you're new to the industry, it's obviously a little bit easier to learn something like this rather than a series of specification sheets. And also the reason for going to this page in a little more detail is because particularly this information down the left hand side of the page here is all fairly standard right through every sheet. Flat option 2 is basically just another very simple straightforward patio, but it gives you the option of a central beam. So if your overall projection is too far for your roof sheet to span, then and you require a central beam, this just gives you the option of inputting a central beam. And it also allows you to put in different spans. So if you span from your fascia out to your central beam, say it was 2.5 metres, but it was 3.5 metres from there out to your edge beam, it will just make all those necessary calculations and work out the beams you require in each location. You can put posts under your central beam if you require. Probably not something that would happen too often other than perhaps a carport where the post wasn't an issue. Usually in the case of a patio, people want a clear span, so you simply select 0 and it will give you a beam that will clear span the whole distance. Obviously you can have overhangs either end, you can have a roof sheet overhang here on the front if you so desire, all basically the same as the first page we looked at, but just gives you the option of a central beam if it's required. Flat option 3 is very similar to the second page we just looked at, where you have a flat patio. You can have 2 different spans or 2 spans the same, whatever's required. You can just engineer just these 2 beams. You can select whether or not you want central posts under these beams or not, and with all the correct data it will give you design correct just for that patio. However, say this was a double carport and you also wanted a small walkway going back into the house, it gives you the option of a second beam over here with a small flat patio on the side, or you can actually have that on both sides. Or maybe you want a larger section on that side. If the dimension in this cell here is larger than in that cell there, it'll format it out here like this. If that matches this dimension over the other side, you'll see it lines all that up and you no longer need post number 6. If that is smaller, you'll see it includes post number 6 again and shortens it up to there. You can put an overhang on the roof sheet, you can put an overhang on the beam. And if you change this cell, it will just to a number bigger than this one, it will just move all of that information up for you. So once again, it just gives you the option of I guess a bit of an odd-shaped flat patio, but also gives you the option of generating a plan that looks similar to what it is that you're eventually going to send into council. Depending on whether these posts are available or not, it will give you all the required post and footing sizes, etc. once all this other data is inputted correctly. Flat option 4 is for designing point load beam patios. So where you might have the requirement for a central beam, but the customer doesn't want any posts out in the middle at all. So you need to run a beam out either end to support the central beam in the middle and just have posts out the front. So once you put all your dimensions in, and once again these 2 spans here can be the same, they can be different, doesn't matter. This will require just the engineering of these 4 beams. If you decided that you needed a larger area, you can put another dimension in here, it will format the page accordingly, and you'll now need to select all 7 of these beams. And obviously if you wanted to put another dimension in the end, it will then engineer all this section for you. So you can do quite a large flat patio using point load beams if that's what you require. It will allow you to put a post on the ends if you want to, and you'll see once you select post, it formats this back to a single line, takes out the double line that is used to format for beams, and as soon as you select post, it tells you this beam is not required. Now if you were to zero that out, you'll see it now moves post number 6 back here and tells you that this beam is not required. Obviously the same thing happens again if you zero that out, moves post 6 back to here, formats these as single lines, neither of these beams are required. If you flick that over to beam, this will go to incorrect, takes the post out, tells you you need to go and select your beam type and your beam size. So it just gives you the option to do it as 1 roof area, 2 roof areas or 3 roof areas, and obviously all this other detail has to be inputted correctly. Once you've selected all your beam types and your beam sizes, you'll get design correct. Each of these pages that have multiple beams to be selected have some buttons up the top here, so if you want to use roll form beam in that whole patio, just hit that button and you'll see it's flicked every one of these beam type cells over to roll form beam, RHS or aluminium. So rather than go through and have to select every one individually, you can just hit the button up the top there and it'll get the whole thing flicked over to the right beam type for you. Alternatively, once you've filled out a page, if you've accidentally saved the program with all that data filled out, there's a reset button on every page which will just zero the whole page back out for you. Flat option 5 is a very simple, straightforward flat patio where you're wanting to run the roof sheet parallel to your fascia. So your beams are just coming out off the house at 90 degrees. You can have any pitch in here you like up to 30 odd degrees, and also you can do these areas as clear span, or you can add central posts. Very straightforward, just more designed, I guess, if you're wanting to just a flat carport, etc. on the side of a house, like I said, with your roof sheet running parallel to the existing structure. Flat option 6 will enable you to do angled patios, obviously designed where, or to be designed where perhaps the boundary on the property is running at an angle to the house. Also, you can add a dimension in this section here, which will enable you to do just a flat patio down the side of a house, and then it might taper off across the end. Very simple, straightforward, but does all the actual calculations for this beam here. Depending on your dimensions, obviously, that you put in there, it will work out the actual beam span. If we make that 2 metres and this projection 4, it will physically work out the beam span of that angle for you, the square meterage of roof sheet and the load that's applied to that beam, and give you the right beam. Flat option 7 is more designed for perhaps doing a carport where they might want to put 3 cars in there, so obviously and you want a 9 metre long patio. If you use those first programs that we looked at, first pages, for example this page here, when you put a central post in here, it just splits your total span in half and automatically puts the post in the middle. When you use flat option 7, you could put 3 metres in there and 6 metres in there, so that you've got a 9 metre carport with a 3 metre opening here for 1 car and a 6 metre opening here for 2 more cars. Now you can do this patio with or without a central beam. If you don't want a central beam, you just select not required, and that's fine. You'll see some strange numbers in here until all this information is inputted correctly, but I don't want to bore you with all of that. If you put required, you'll see it'll add a central beam, line your posts up with the front posts. Obviously you don't want these posts out in the middle of the front span, and so then you can do a 9 metre by 6 metre carport with some offset posts in it. You can put a beam overhang on the end, and you can, if you change this drop down box to overhang, you can put an overhang on the end. If you want to put a third different span in there for some reason, then change that to width 3, and you'll see now we've got a 3 metre span, a 6 metre span, and a 4 metre span. Once again, you can change this to an overhang, put a small overhang on the end, or if you wanted to make another span, it will do that for you. So now you have 4 bays, all different spans, and down here you can select whichever beam is required for each particular location. Not a page that will be used overly regularly, but it just gives you the option of designing that sort of project occasionally when it's required. And you'll see all these here saying incorrect. If you pick there that the central beam is not required, you'll see down here straight away you don't have to select any of these beams. But as soon as you put in there that the central beam is required, you now have to select all those beams. Like all the other pages, once it's all filled out correctly, you get design correct down here, and that becomes a certificate that you can send to council or to your certifier. This page will work out a hip beam for you to a maximum roof pitch of less than 10 degrees. So obviously if you've got a flat patio, you're wrapping around the corner of an existing house, this will allow you to put central posts down either or both of your edge beams, and it will also calculate the hip span for you and then tell you what size beam is required for that hip, and it will also give you the load back on the existing structure. All the rest of the information obviously is the same as all the other pages. You can have beam overhangs, roof sheet overhangs, all that type of information. This is a little gable patio that's designed with a little aluminium non-structural ridge extrusion. It's fairly specific to just 1 or 2 patio companies, so I won't go into this particular page at this time. This is the first of the larger type of gables that you can build with roll form beam, RHS or aluminium. I'll just quickly fill out some of this information. One of the differences here is we have to select a roof sheet pitch. We'll make it 5 metres by 5 metres. We'll select a point load beam at the front. We need roll form beams at each of these locations. Better select the footing type, which I nearly forgot. From there we can select our beam sizes, and you'll see we need a 150 ridge beam, 140 for our projection beam, and a 150 point load beam. If we put our usual information in here, select our state, give it a name and a date, and you'll see from there we select a post. We'll just select a 90mm to make it easy, and you'll see we have design correct. So what we've done is just engineer a straightforward little patio. Gable patio, we can put a overhang on the front if we want, and you'll see straight away our design's gone correct because because we've added all that extra load to our point load beam. So if we upgrade our point load beam, we're back to design correct. Now if you want to add a flat section to one side or the other, or both, we'll make that say 4 metres wide with an overhang, and you'll see straight away our design's gone to incorrect. Now there's a number of reasons for that. One, we need to select our beam type and our beam size, but you'll see now down here it says incorrect because our roof sheet has a maximum span of 4300 and we're asking it to span 5 metres because of this dimension we have over here. So we either need to reduce that dimension or increase our roof sheet. Now you'll see even 0.48 is not going to do it for us, so we would need to go to some kind of insulated panel, and I'll just pick something silly at this point just to do the job. So you'll see now that our roof sheet span is greater than what we're asking it to span, and our design has gone back to correct. Obviously the same thing applies if you add a dimension to this side. Straight away the design will go to incorrect until we fix our beam size. From there, the next page that we'll go to is basically the same gable patio, except it also has the provision of putting a point load beam across the middle, and the flat sections on either side are for roof sheet going at 90 degrees to the gable. So, and I'll quickly fill this one out as well. So we'll make this a 5 metre by 5 metre gable. We'll put a 500mm overhang on the front. So if we go through, select our ridge beam, which I haven't selected because I've missed it. Select our ridge beam, we'll put a point load beam there, and you'll see it's added posts either side, and we'll select a point load beam for the front. Now, if we go through, select our beams, type and size at each location. As with all the others, add our custom information. Select the post size, we'll select a 90 by 90 again, and you'll see our design's correct. Now if, as I said, you wanted to add a flat section on either side, one side or the other or both, we simply put our dimension in, and you'll see straight away our design's gone to incorrect. We'll put an overhang on our roof sheet. From there we simply select whether we want posts or not in this side. So we'll select one central post, line it up with our point load beam, select our beam type and our beam size, and you'll see our design's gone back to correct. The other options that we have in the gable, if we select, as we did before, our point load beam gives us a post both sides, we can select a point load beam with no posts. Now you'll see straight away the whole thing goes to incorrect. We need to choose much bigger beams and need a larger point load beam. If we choose posts with no point load beam, now we need a bigger ridge beam, bigger point load beam, and obviously now these beams can actually be smaller because they're not spanning such massive distances. Also, we have the option where we can select not required, and that will make all three of these beams span the whole distance. And once again, each time you change those options, your design goes to incorrect until you go back and fix it. So you'll see that gives you a 9.5 metre wide patio with a projection of 5.5 metres, of which 5 metres is a gable. It's quite a big patio, but you can engineer that very, very quickly and easily. If we add the same information out the other side, we'll clear span this end just for interest's sake. And you'll see we obviously have the same beams on both sides of our gable now because they're carrying the same amount of load, and our design is back to correct. So once you get used to the program, you can very, very quickly and easily design some quite large, complex gable patios. This is basically the same thing as what we've just looked at, but when you add flat sections to this side, or if you add flat sections to this particular patio to either side, it actually runs your roof sheet parallel with your gable and includes a central beam if it's required. So other than that, everything else is the same as the gable patio, gable option 2 that we just completed. It just has the roof sheet on the flat roof running parallel with your gable. Gable option 4 is for a split gable, so you see you have two ridge beams. Once again, there's some little photos so you can see the type of patio that you're designing on the particular page, which makes it a little bit easier, like I said, for new people. All the rest of the information is the same. You now obviously have a left and a right roof pitch, because they can be the same roof pitch with a different dimension either side, or they could have the same dimension both sides and be a different roof pitch, all that type of thing. That's all it's all calculated, and it also gives you the distance between the top of your two ridge beams once you've got all this detail selected. So if you want a particular distance between your two ridge beams, or your customer has asked for a particular distance, You can just keep manipulating the roof pitches and the dimensions and all that type of thing till you come up with the particular gap in between your two ridge beams that you're looking for. On each gable page, it'll give you the height of your gable. Once all the information is inputted, you'll see over here it tells us our gable in this instance is 1.136 metres high. So all the gables have that cell. Gable option 5. Quickest and easiest way to explain this page is to show you the picture. You'll see it gives you a front edge beam or point load beam that will span greater than your gable width. So if you don't want posts directly underneath the projection beams of your gable, this is the page you would use. It gives you the option of central beams in the flat sections either side if they're required, but both of these cells have to have a dimension in them. If you don't want it one of these cells has to have a dimension in it. If you don't have a dimension in at least one of those cells, you might as well just go back and use one of the other gable pages. Gable option 6 just designs a gable running parallel to the fascia and gutter of your house. Obviously you'd need in most cases some kind of box gutter system along there. With this one you can design it with your point load beam or with a central post at each end. So you can have your point load beam or you can have a central post, and see it adds your post for you. And in the middle we need to select a beam type, which we can't do until we put a gable width in there. Select a ridge beam. We can put a point load beam in the middle, in which case it will add a post over here, or we can select not required and it will just calculate a ridge beam and an edge beam that will span the whole distance. You can have an overhang on one end or the other, or both, as in the rest of the pages, and it will just format that all for you. All the rest of this detail obviously is the same as it is before. Once all this data is input correctly, you'll have design correct and a certificate obviously for council. Gable option 7 is very similar to the flat patio that we looked at before, where you can design your gable. In this case we've got a 6 metre long by 4 metre wide gable, and then you can add a small or large or whatever you require flat roof on either side. So maybe that might be just a little walkway going into the front door of a house. Maybe they want a gable carport out the front and just a covered walkway to get to their front door. You can do that little flat roof on one side or both. You can put a bigger flat section on the other side if you want to, and it will calculate. If you select to have a post in here, for example, if we select it like that, it will just calculate the load on this beam and the load on this beam, and the beam in this drop down box will just be the worst case scenario of the two, and the same over this side. So it doesn't give you the option of obviously of two different beam sizes at the back and the front. Obviously you're going to, just from an aesthetic point of view, you're going to put the same beam all the way through. So this just calculates that span and this span and gives you the worst case scenario. The same options are all available in there. You can have the point load beam without the posts, you can have the posts without the point load beam, or you can have not required, and it will just make all three beams span all the way to the front and pick up these point loads on the way through. It's a fairly straightforward gable patio, I guess, but it just gives you these options of one or two little flat patios either side. Gable option 8 is a little bit more complex. I won't go into too much detail with this, but you can put in width 1 and width 2. So maybe you've got a 2.5 metre wide gable. You can select the pitch of your gable all the way up to 30 degrees, or it can even be a flat patio. We'll just make it 20 degrees for the sake of the argument, and I'll quickly actually fill this information out because it's probably worth having a decent look at this particular page. So here you can select whether you want a third section of roof out here, or if you want that just to be a roof sheet overhang. So you can actually put an overhang on the sides of your gables. Now you'll see when that's a roof sheet overhang, you don't need to select the pitch because obviously it's working off this pitch here. You can then select whether you want a point load beam or a central post under here. So effectively you've just engineered a small gable with an overhang on either side. If you change that to width, you might want that to be 3.5 metres with a 500 overhang. You'll see this has gone to incorrect because now you need to choose a pitch. So this is more designed, perhaps if you're putting a patio on the existing gable end of a house where it's got perhaps a 5-degree existing veranda on the house and then a 20-degree pitch to the house. So you can come in at 5 degrees here, go up and over the pitch of the house, and you can also obviously add the similar width to this side with or without an overhang if you like. Select your pitch there. So you've effectively just matched the existing veranda, gable, roof and veranda again of an existing house. So a little bit of a complex page, that one, but it won't get used a lot, but obviously gives you the option of building a few different types of gables or potentially flat roofs as well. The last page is for engineering decks, and I'll just very quickly fill some of this out just to explain to you how it works. With your flooring type, you can choose timber decking or flooring, particle board flooring or compressed sheet and tiles, obviously depending whether it's a deck or a room or whatever it is. You can choose live loads of 1.5 kPa, which you'll see are for residential decks up to 1 metre high and all residential room enclosures. 2 kPa is for open residential decks over 1 metre high. And then we have 3 kPa, which is for commercial projects. Post heights go all the way up to 4.2 metres. And we'll just quickly put in, we'll make this 9 by 6.5. You can select the number of posts that you want along here underneath your edge bearer. You can select whether or not you want a central bearer. So in this case, we're trying to span 6.5 metres. We'll put a couple of central posts under our central bearer. Then we simply need to select the joist type, whether we want roll form beam or RHS. In that instance, we get away with a 140 by 50 roll form beam. Our edge bearer, we'll use an RHS for this instance. We only need a 100 by 50 by 3. And for our centre bearers, we have roll form beam, RHS or universal beams. So you'll see we'd only need a UB, a 150 at UB 18. Select our post size. See, we need a 75 by 3.5 steel. The one that's missing in here is an 89 by 2 mil steel, which obviously is not quite as strong as the 3.5. And like all the rest, put our customer information in. And you'll see we have design correct. Down the bottom here for the second deck, it's telling us not required, but if as soon as we start to put information in here, that will slip over to incorrect until we filled out all the information for the second deck correctly. Every page has an instructions page on it, so obviously they're specific to the individual page that you're on at the time. So if you have any issues with filling out the page, that will help you with some details. You'll see as you select this information here, it gives you the bearer span. When you select this information here, it will update your joist span for you so that you know how far you're trying to get a joist to span in any given situation. And obviously it will give you your bearer span for your centre bearers depending on how many posts you choose for the centre. So all the information is there on each page to get a fair idea of what it is and how it is that you're designing your timber deck. Footing sizes are also provided, and in the engineering manual gives you details on bracing depending on the height of the deck that you choose. So the final page, and obviously it's not a certified page, it's just there for a bit of general information and perhaps to help people out when they're designing patios and using or decks and using some of the larger beams. For example, you know, if you use a steel universal beam, they can get fairly, that was 7 metres long, it'll weigh 127 kilos. So although there's the option in the program to use some of these larger beams, obviously people need to be aware of the weight that some of those beams are. Obviously if you're the builder out on site, there's a few precautionary things that need to be put in place to make sure he's not left there with a 127 kilogram beam. Like I said, it's just there as a general information page. So that's the basic rundown of the whole attached structures program. I can be contacted anytime on 0437 851 445 if you have any questions or queries. Thanks very much for your time. Thanks for watching.